like I said, this is our last section of Unit 9 before our test. So today's April 1st. We're covering Pythagorean theorem and distance formula. Your test is a week from today. So we're going to take today to do the notes, and then we'll have a couple of days of practice. There are going to be 2 9.3 practice assignments, the same as there was for 9.1. One will be a worksheet and one will be Delta Math. Oh, they're in the room somewhere. I have 2. Looks like there's one over there on the ground. Lost my train of thought here. Okay, so we're going to have a worksheet practice and a Delta Math practice, just like we did for 9.1. If you finish these and have time to spare, then you should be working on missing work. A lot of y'all are missing the 9.1 worksheet from last week. And then we've had 2 Delta Maths, 9.1 and 9.2. Okay, so just a heads up, that's the plan for this week. Friday, you'll get your review. You'll have Friday to work on the review on your own, try the problems, and then we can go over any questions that you have and clarify things on Monday. And then your test is Tuesday. I will not be here on Friday. I have a meeting, but like I said, you're just going to get the review handed out to you, and that's what you should be working on. Okay, so that's the plan. Can y'all please stop talking?
If you heard the lore this file, that as of this weekend, you'd understand.
Well, y'all can talk about it at lunch. We're going to take our notes right now. Okay, so Pythagorean theorem. Hopefully, hearing just that phrase, Pythagorean theorem, rings a bell for you. I believe you originally learned Pythagorean theorem in middle school, intermediate, junior high, whatever you went to for your middle years. And then you definitely used it a lot in geometry. Okay, some of you took geometry last year, so it's been a couple years. Okay, but Pythagorean theorem is a way for us to find the missing side length of a right triangle if we know the other 2. Okay, so we label the triangle sides A, B, and C. So we'll label A, B, and C. Now, which you label A, B, and C does kind of matter. The A and B are interchangeable as long as they are the legs of the triangle, the 2 sides that meet at the 90-degree angle. So I could have said B here and A here. A and B are interchangeable, but the C has to be the hypotenuse of the triangle. Okay, if you don't remember that term, it's the side across from the 90-degree angle. Okay, I'll label it hypotenuse. Okay, so C has to be the hypotenuse. A and B, those are the legs. Okay, so there's 2 legs and a hypotenuse in a right triangle. So the formula for Pythagorean theorem is that you take A squared plus B squared, and it will equal C squared. Okay. Does that ring a bell? Do y'all remember that formula? A squared plus B squared equals C squared. All right, so let's try and use that formula on these examples here to find the missing side length of the triangle. It says round our answers to the nearest 10th.
Do we have to do
No, we're not doing trig. That's going to be next unit, actually. We'll do right triangle trig. Right now, we're just doing Pythagorean theorem, and we'll learn distance formula on the back. Okay, so here, actually, before I do any examples, I'm just going to label everything. Okay, so in all of these triangles, I'm going to label my C, okay, my hypotenuse. So across from the 90-degree angle is C. Across from the 90-degree angle. Just make sure you're getting the right side is the C. Okay, now the legs, what's left, A and B are interchangeable, so it doesn't matter. I'll just do A on some of them. And B on the others. Easy enough to label, right?
Super right.
All right, so now we're going to set up the equation then. So I'm going to zoom back in. All right, so for this first one, it's going X is the missing piece. That's A. So A is our unknown. We know B and we know C. So I'm going to say X squared plus 6 squared equals 10 squared. So A squared plus B squared equals C squared. And I've plugged them in. Okay, so now I calculate the squared values. So 6 squared is 36. 10 squared is 100. Okay, and now I start solving. Now, if your missing piece is the C term, like in this next one, you're just going to add these two numbers and that's it. But when A or B are the missing piece, you're going to have to move the other one to the other side to isolate the missing piece. So I'm going to move the 36 by subtraction. So I have X squared equals, and then I'm left with 54. Oh no, sorry, 64. Okay, now who remembers the opposite operation for a square? The opposite operation for adding was subtracting. The opposite of multiplying is dividing. What is the opposite of squaring something?
Triangle.
Good one. Let's look at Desmos keyboard and see if that helps ring any bells. If you see anything on there. There it is, square root. Okay. So if you look at your keyboard here, okay, you can see you can square something here. Okay, and a few under that, there's your radical, your square root. Okay, those are opposite operations. Okay, so we want to take the square root to get rid of the square. So I square root, what you do to one side, you do to the other. So the square and square root cancel each other out. And X is 8. If you don't know that the square root of 64 is 8, what tool can you use? If you couldn't do that in your head, what do you have at your disposal? Yeah, you could use a calculator. Okay, go to type it in Desmos or use one of our handheld calculators. Okay, so I would just type this in. I'll show you what it would type in as. I would just do the square root of 64, and you can see that's 8. Now, not all of these are going to be integers, I don't think, and if it comes out to a decimal, round to the nearest tenth, which is one number after the decimal. Okay, so now I'm going to set up this second one. So my A and B are both known, 9 and 7. So I've got 9 squared plus 7 squared. And then my C is the Z, the unknown, Z squared. So now I will calculate. 9 squared is 81. 7 squared is 49. And then this is what I was talking about. When your missing piece is the C, you don't have to subtract anything. You just add those together. So 81 plus 49, you get 130. So I've got 130 equals Z squared. And then the last step is to take the square root. So this one is not a perfect square. So if I type in square root of 130, I get 11.40175.425, blah, 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 blah. Okay, but I'm going to the 10th. Remember the 10th place is this one right here. And you always look 1 over to see if you should round up or not. The 0 does not round the 4 up. So this is going to stay 11.4. Okay, so this one again, C is the missing piece. So my A is 5, B is 7, C is Y. Now, you could individually do what I've been doing, square each number and then add them, or if you wanted to do it all together at once. Guys, we're trying to get through a lesson. Don't touch each other's stuff. Give it back. Don't talk. Just follow along. Ask questions if you have questions, but quit goofing off. All right, so then 5 squared is 25. 7 squared is 49. If you wanted to do that all at once in the calculator, just type in 5 squared plus 7 squared. It'll work the same. It comes out to 74. So we end up with 74 equals y squared. And then we have to take the square root. This one is not a perfect square. So we're going to have a decimal and we're going to round to the nearest tenth. And it comes out to 8.6. Actually, this next one is missing a label. C is not labeled and K is missing. We can't do Pythagorean theorem unless we have 2 known sides. So instead of making up a side and doing it, we have enough examples. We'll just mark through this one. We can't do this one with the information given. We can't use Pythagorean theorem with the information given. So we'll just move on. Okay, now in this 4th one, again, A and B are known. So that is 6 squared and 3.5 squared. And that will equal m squared. Now here's what I'm talking about doing it all at once in the calculator. Instead of separately doing 3.5 squared, and I already forgot what the other number was. 6. Instead of doing those separately like this is one way you could do it. Okay, and then you could add those 12.25 and 36 together. Okay, that's step by step. You could enter it all at once as 3.5 squared. Make sure you get out of the exponent plus 6 squared. And get the same thing. Okay, so you can do it all in one line here, or you can do it step by step. It gets you to the same 48.25. And then we have to get rid of the square by taking the square root. And you can type it in Desmos, or you can also copy and paste. So whatever you prefer to do. So now this one, I would look here at the 4. The 4 does not round the 9 up, so this is going to stay 6.9. All right, last but not least for Pythagorean theorem, this time my missing piece is A. So we've got n squared plus 2 squared. B is 6. So when I calculate, I do have to do these. That's going to be 4. And then I have to, that's 36, subtract that 4 to the other side. And then take the square root. So I'm going to do the square root of 32 comes out to be, now I will show you this one in Desmos because this one does round up and I want you to see one that rounds up. So the square root of 32, 5.65, blah, 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 blah. We're going to tenths, which is the 6, but the next value is a 5. So it rounds the 6 up. So this should round to 5.7. How do y'all feel about Pythagorean theorem?
Easy, lemon squeezy.
All right, let's apply it. There was a terrible storm last week. A tree fell and the top rested on the edge of the roof of Dave's house. His house is 12 feet tall. The base of the tree is 9 foot from the house. How tall was the tree that fell on Dave's house? Okay, so I would always recommend in word problems drawing a picture. Doesn't have to be extravagant, but we've got the ground, we've got the house, and we've got a tree that's fallen on it. Okay, so this is the tree, this is the house, this is the ground. Okay, so you have a visual of what's happening. The tree has fallen onto the roof of the house. They tell us that his house is 12 feet tall, so 12 here.
Real.
And they tell us that the base of the tree is 9 foot from the house. So the bottom of the tree is 9 foot from the house. So this is 9. So that's my A and B. Remember, label your A, B, and C. So A, B, C. Okay, so C is always across from the 90-degree angle. So the length of the tree, how tall is the tree or how long is the tree? That's what we want to know. So when I set this up, it will be 9 squared plus 12 squared equals C squared. Please stop talking. So we know 9 squared is 80. Oops, don't want red. 9 squared is 81. 12 squared is 144. And that together is 225, which is a perfect square. If you go to take the square root of 225, we get 15. Now, when you have word problems, you want to answer in the context of the problem. So I'm not just going to say C equals 15. I'm going to answer the question. How tall was the tree that fell on Dave's house? Everything was measured in what units? What units did they give us? Feet. So the answer is the tree is 15 feet tall. So word problems should be answered in words. Okay. And make sure if there are units provided, okay, that you were measuring with, that those same units are on your solution. All right. All good with Pythagorean theorem? We'll stop there because the bell will ring in a couple minutes for lunch. We'll do the back when we come back from lunch.
Did you remember?